Good morning friends. I hope everyone is doing well. In the last video, I have discussed about what is an NFA, why it is called an NFA, what is the representation of NFA, all these things we have discussed in detail. In this video, let me discuss few examples for how to construct a NFA. Let me read out the question. Construct a NFA over alphabets A, B for a language L1 consists of strings length is exactly 2. For the same language we have constructed the DFA. Now I will discuss how to construct the NFA. So what is the language L1 will consist of? Exactly length 2. So you will have AA, AB, BA, BB. Okay. So for this language I want to construct an NFA. So I will construct the Q0. I will take it as an initial state. On A, B, I will reach to a state called Q1. I will reach to a state called Q1. Q1 on A, B, I will reach to a Q2, which I will make it as a final state. Is it clear? If you see that AA is accepted, AB is accepted, BA is accepted, BB is accepted. Now if you see that, I can say that this is an NFA. Why I can say an NFA? From Q2 on A and B it is not going anywhere. So I can say that it is not a DFA and it is an NFA. For the same question, if you ask to construct the DFA, we have discussed the example in the previous videos. You can go through it. Anyway, I will construct the DFA for the same question. Q0 and Q1 on A and B, you have a Q2. Q2 on A and B, you will go to a state called D, which will act as a dead state. So this is the DFA for the language L1 and this is an NFA for the language L1. If you see that what is the difference, for Q2 on A and B, we no need to go in an NFA from a state on alphabets. You can go to more than one state or you may not go to any state. So that provision is there. So on A and B I have not represent because I will worry only about the string acceptance. What are the set of strings are there in the language L1? They should accept and others I will not bother. Whereas here if Q2 on A and B I have to represent. It cannot go to any unreachable, it means any other reachable state. So that's why I am going to a dead state. When it is, why it is called as a dead state? From the state, Q2 is the final state here. Sorry for it. Now from this D, I cannot able to reach the final state. So I can call this D as a dead state. So what it is doing? The string length more than 2 is eliminating here. So that's why it is taking the string length exactly 2. Whereas it is only worrying about the string length exactly 2, not worrying about lengths more than 2. Is it clear? So that is the difference between an NFA for the given language and the DFA. Okay. So for better understanding, let me take few examples. We will change a little bit. Instead of exactly 2, at least 2 we will write. Okay, we can write it as at least 2. Same question we have constructed the DFA. At least 2 means the length can be 2. Length can be 2. It will consist of length, strings of length 2, length 3, length 4, so on. So with length 3 you will get 8 strings. With length 4 you will get 16 strings. With length 5 you will get 32 strings. So on, you will get infinite number of strings. So I can call this language L1 is an infinite language. So for this one we will try to construct the NFA. So Q0 is my initial state. So on A and B I will go to a state called Q1. Q1 on A and B I will go to state Q2. Now it is accepting a string lengths 2, but I should accept more than 2 also. I will represent like this. So it is accepting string lengths of 2, length 3, all these things. For this question, the NFA and DFA will be same. If you have a doubt, you can construct the DFA. It will looks exactly, sorry, I am forgetting. You have a Q2 will act as a final state. So you have 3 states. Out of that, initial state is Q0 and final state is Q2. If you construct the DFA also, it will look same as it is. If you want to check whether this NFA is correct or not, you take AB. The length of the string is 4, so it is more than length 2, so the string belongs to language L1. We will check it whether it is accepting it or not. Q0 on A, we are reaching to a state called Q1. Q1 on B, we are reaching to a state called Q2. Q2 on A, where I am reaching? I am reaching to Q2 itself. Q2 on B, I am reaching to a state called Q2. So from the initial state Q0 on AB string, I am reaching to a state called Q2, which is a final state. So I can say that the string is accepted by the NFA whatever we have constructed. So for the same language, if you construct the DFA, it will look same. If you have a doubt, you can check it. So now let me discuss another example for better understanding. At most 2. Length is at most 2, we will do it. Okay, at most 2 means it will accept the long strings of length 0 is epsilon, length 1 it will accept, and length 2 it will consist of. So the language L1 consists of the finite number of strings, so I can call it as a finite language. It consists of length 0 strings, length 1 strings, and length 2 strings. As it is having epsilon, if I construct the NFA, I should accept the epsilon. So my initial state will also act as a final state. Now I need to accept of length 1. So my Q1 also will act as a final state. Okay, of length 2. Length 2 also I should accept. So my Q2 also will act as a final state. So this is my initial state. On epsilon we are accepting, on length 1 we are accepting, at most 2, so maximum length can be 2, so you are accepting of length 2 also. This is the NFA. If you have to construct the DFA for this one, on this, if I construct the DFA for this language, on Q2 on A and B, you will go to a dead state. If you want to check it, you can check it, because here in NFA, on Q2 on A and B, we have not disclosed, because what is the NFA property? From a state on input alphabet, you can go to more than one state or you may not go to any state. So using that property, Q2 on A and B, I have not disclosed. When it comes to DFA, I am not, let me write the entire DFA. You will have A on B on Q1, Q1, let me write here so that it will be visible to everyone. Q0 on A and B, you will go to Q1, which will also act as a final state. On Q2 you will reach. Now Q2 on A and B, you will go to a state called dead state. Why it is called the D as a dead state is, from the state D you cannot reach to any of the final states. So this is the DFA for the given language L1, and it is an NFA for the given language. So NFA construction is quite easy as compared to the DFA. So in the next video, I will discuss few more examples for better understanding. Thank you so much.